All right, so who am I? My name is Erik Bouvin. Work as a data vault modeler and data engineer, as it's called now, not ETL or ELT engineer. I work for Top of Minds in Stockholm, Sweden, and Top of Minds is the data vault preaching company #1 in Sweden, and one of the founder of Top of Minds is Hans Hultgren, which I guess most of you guys know that he's one of the founders of Data Vault. So we are having courses to our customers and also to other consultant companies in Sweden. And I started my career in 2005 working with SQL Server 2000 and DTS packages, dragging data from left to right with no modeling in it. But now, a couple of years later, working heavily with modeling, and also the past 2 years, we're working with DBT instead of the DTS packages that I started with. But I love my job, I really do. But when I'm most passionate is when I take this jacket off and put this one on, because I'm also a football coach for my son's team in Älvsjö AIK. So that was a short presentation on myself. And what I'm going to talk to you about today is that most of us, well, all of us, I guess, are working with ensemble modeling and possibly Data Vault in particular. And one of the key strengths with Data Vault, right, is that we can add information. Add more hub satellite links without doing any re-engineering or reloading of the existing ones. But in our projects, the Data Vault model isn't always, or in my case, has never been the final step of the implementation. So, because that is out here in the data marts, which uses Kimball-style modeling, where we are and that modeling approach isn't as agile as the Data Vault. So how can we keep the data marts up to date as per the Data Vault modeling without doing a lot of reloading and such? And that is the topic for today, where I will show you how we can use Twine to be more agile from the Data Vaults to the data mart. So, and my expectation of you is that you are experienced with ensemble modeling, that you know the nature of it, and also if you will work with the Kimball dimension and data mart modeling, those different kind of approaches. But you do not need to know anything about what Twine is. That is the purpose of this session, that I will tell you about it. And also, please ask questions. It's highly likely that I will go, if you guys have seen the Muppet Show, there's a Swedish chef, right, who's mumbling a lot. If I start doing that, please pause me, Christian, and ask questions if I hasn't been clear enough. All right. So the Twine agenda for today will be, first, I will talk about how we can keep facts and dimensions, which isn't a SAD of type 1, how we can keep those in synchronize with each other without any semi-automated or manual reloading. And the second part will be where I will show you how we also can use the Twine to go from ensemble to dimensional, bypassing the point-in-time artifact, which is heavily used. And last but not least, hope we'll have some Q&As and discussions. All right, so that's it. I will just I will turn off my camera right now and put it back on after the first session. Okay, so when you start a new project, it could go something like this, that we will start with a first phase. And in this case, the product owner has decided that we should implement a data vault and also a Kimball data mart, for sales by timing customers with historizations in customer dimension, and use the timeline when it happened, I stated here. And then it's when it happened, not when we got to know that it has happened. And the sprint master has set up 4 sprints. The first sprint will be set by time, add then the second one, add the customer pre 1 to 3 attribute, and then go to the fourth one where we'll add the last ones. So the implementation kicks off. So we're now in the first sprint, where in the data vault model we add the sales ensemble, but we're smart enough as well, right, that we are populating the customer hub with the customer IDs that we have in the sales in order to be able to put the link up. But in the fact table, however, we create the D customer key here, but at this point in time, we do not know anything about them. So we just leave it for now, and then we add the date key and the metrics, and we evaluate, and the test manager is happy because we have the data that it was as it's supposed to be. All right, and then going to sprint 2, we start adding our first 3 top prio customer attributes. And in the data vault model, easy, right? We just add a new object. We don't reload anything. But whereas here out in the Mart, now we have a customer dimension, but we also have the sales here, right? But here we don't have any customer information, so we need to reload this fact table. And the product owner asks you, right, why do we need to reload it? And you say, well, we didn't have any information of the customer in the first sprint. And he is happy with that, of course, because he understands that we didn't have any customer information. All right, we move on to the third sprint. We add more things in the data vault. Everything goes smoothly. But in the data mart section here as well, we have added our 3 new attributes with history, meaning that the previous the data that is here in the sales fact is having incorrect keys. So we need to reload it again. And the product owner, right, he doesn't understand why, because we have added the customer data before, right? But you say, well, now all the customer has a new timeline, and therefore it needs to be reloaded. And of course, it iterates again over here. Now the project phase 1 is done, but then all of a sudden you have realized that the first satellite you implemented, the source system hasn't sent anything for 3 days due to a problem. And what happens then, right? That when you have that data updated, you need to reload the fact again. And this is a situation that we really do not want. So how could we do so? And I guess many of you has a similar approach to it that we have in the data mart sections. We have an ELT or ETL destination, and also we have another object for the end users, because when we have that, we can be flexible with handling time and other things in between. So if we would, for instance, do like this here, we are doing select from the table, doing a range join to the joining to the customer with the range join, and that is likely suitable. But as more history comes in, as more dimensions we add, the query performance possibly will not be really good. And that is actually what happened in a project that I was in more than 3 years ago, and we needed to find alternatives to be handling the data marts in a more in this agile fashion, but with better performance. And I started look around a bit and got a really good tip from my colleague Daniel, who said, well, I read something about the thing called Twine, and it seems to be doing what you want to achieve. So then I started reading about the Twine, which is defined, or was defined at least 3-4 years ago, like this, that a Twine is an efficient set-based algorithm that can be applied when you have a table in which you have recorded a history of changes and some other table with related points in time for which you want to know which historical rows were in effect at those different time points. It's a long sentence, and it took me probably 3-4 rereading of it to understand it. But if I will try to explain it to you, it would be a little bit like this, that here we have 2 timelines. And the first one here on top is the instances of me in the customer dimension. Here I joined the company where I buy things from, and here, I don't know, I moved or something. You get it. And here I don't know, I aged 1 year and then I moved here again or something like that. And on the bottom here, you see my sales transactions, which isn't that many compared to my dimensional changes. But what a Twine does is that it kind of unifies these 2 timelines into one, and then look at, for this point in time of sale, which version of Erik was valid at that point in time. And in this case, right, this version of me was the one that was active. And for this sale time, it was this version of me. And this is mapped this. This also mapped this. And this transaction was to the recent version of me in the customer dimension. Okay, and if we look on a code example, the Twine looks like this, where you have the tables or models that you want to Twine, in this case, the sale and the D customer. You create this unified timeline, and also you're defining these. And over these, you are using this this function here, this sliding window function, that tells you at this time point, this customer time, this time point was valid from that, and then we're filtering on the timeline of the fact that we want to choose. Okay, so with my finding, okay, sorry, and the Twine, the output of it could look like this. So I created what I called the T sales customer, which would be partitioning on the date key, which again is resembled to what sale at the sale date, and what customer and which version of me that was valid from. So here we have a range. Here we have a list of partitions with the customer, in this case only one, and what version of the customer that was effective at that point in time. So happy as I were, I went back here to see whether or not I can improve the performance of this view. But then it looks like this. It went from joining one table, the D customer, to 2 ones. And the reason for it, right, is that I still needed this customer key, which is the instance of a customer. And I can't remember, because this was 3 years ago, whether or not this improved the query compared to the range join. But still I wasn't happy, so I did a little revisit of the Twine and extended the code. And the only difference is that I'm rejoining the dimension that I used here inside the Twine in order to get the customer key out. So the output here instead is that I still had the same date key that resembles, in this case, to the fact sales date key, which we partition by it, but then now we have already here the instance, we have the D customer key here. So moving back again to my sales view here, I changed the code from this to this, which improved the performance a lot. And here is where things got a little crazy, because what we did try after this is that we tried to update the fact sale table with the key, the D customer key from the Twine. And this actually worked quite well with the setup that we had. So for this case, the sale fact, it just reads exactly all the columns from the ELT destination table without any joins at all. And we did an implementation of this at one of our customers a couple of years ago, which was based on an Exasol cluster. I can't remember how many servers it was, but it were more than 3, less than 10. And at 3 years ago, we had 19 fact tables, which were retwining on a daily basis. It was roughly 7 billion transactions and 65 million rows in the D customer table, and a full history retwining of all those 5 years that we had in those marts. It took around 15 or 20 minutes. And the largest fact table, it took 7 minutes with 3.5 billion transaction with 18.8 million unique customer versions. So yeah, quite a decent amount of data in it. And as we speak, this implementation has been up and running for more than 3 years. I checked with the company 3 days ago and asked if there's been any problems with it. And it actually has gotten that they don't even when I asked them, they were, yeah, true, yeah, we are using it, but it's automated, so we don't never think about it. And also, before leaving, I did after the implementation, I actually did a Twine versus range join test with this largest fact table to see the performance. With the setup that we had, the Twine was roughly 100% more efficient than doing a range join with a similar setup. And with using Twine, we can always have a fact and the dimensions are always in sync with the timeline of your choice. And there's no need for lookup to dimension when loading data. And with that, there are minimal ELT pipeline dependencies, because if the customer data is, for some reason, the source system has issues with exporting it or any other reason, they will always be in sync, and all other data ensembles can still be pushing data without any, this stop in the data pipelines due to the minimal pipeline dependencies. And also it has a really strict pattern that makes it really easy to automate these kinds of implementations. And with it, no manual or semi-automated rekeying scripts or updates when the data is out of sync. And yeah, and with it, we become agile all the way. So here is where the part 1 ends, and I will put my camera on. Likely, I need to re-explain something if anything was too fast or so.
I don't see any questions so far. Questions?
I have a question, just a curiosity really. How large source tables or how large of data vault tables have you tried this on? Have you gotten sort of where it becomes inefficient at a certain size? I'm thinking about, you know, huge transactional tables, etc.
I'm just going to back up a bit here. And all right, so what we implemented was this pattern, but of course you can restrict the amount of data, the amount of partitions you need to do, but you also need to be aware it's not only based on, for instance, let's say that we know that yesterday's sales, that's the only partition that has been updated. It's not only to, you cannot not simply use a filter like that, because you need to reconsider the dimensional data as well.
Yeah,
so
that was my thinking. The incremental logic becomes
because
slightly more complex.
It is. So let's say here, for example, we take this one. This one. We know that, okay, this is the date of the 19th of September, 2023. So if we will only do retwining of that partition, and in combination that there should have been customer updates here, but those customer updates, we become aware of that 3 days later, that it actually happened. So you need to, you cannot be you need to be aware of both of the timelines in this example, but you also need to be be a little bit pragmatic as well. So what we did is that let's see, where were we? Here. I think it was that after that, both in this case, the sales table and also the customer dimension had been loaded for that day. Let's say that we only did a batch load once a day. That when both of these, or when when both of it has been loaded, then we would do the retwine that day. But then we had a kind of a week, I think, that we retwined 1 week, and then on off working hours, we were retwining the full table.
Yeah. Okay. Thank you. Yeah.
So
gotcha.
So I think you need to be medium smart when you start with this incremental retwining.
Yeah. Thank you.
There's a question in the chat from Dimitri where he asks, on which database engines do you anticipate performance benefits from twining, apart from Exasol?
I don't know. It's if you have a similar approach like this, I guess test it out. I'm currently working in a project where GCP is the platform, and I'm not confident that BigQuery will handle it well. Let's see. And I'm aware of there are more similar concepts as Twine. So just try them out. And what we did find also is that, because first initially we thought that, yeah, let's have one big Twine for all. We have 19 fact tables, right? So first we thought, yeah, let's have one big one that will include all the dates in all the fact tables. But that didn't play really well, because we have one with complaints, and that was very, very low with data volume compared with this one, the sales, the biggest one. So that had some negative effect for basically all the tables except the large one. So my recommendation is to have one Twine per fact table, and also in combination with one Twine per dimension. And again, they're so easy to automate. So if you have a good technical setup, all you need is configuration in order to generate these. I see Lars Rönnbäck is here. I don't know do you want to comment anything about the definition of Twine that I possibly didn't do well?
No, I think you captured the definition quite well. Like you were showing, it's basically the intertwining of different timelines into a single timeline, over which you then use a window function with a range. So that's basically the definition. And I can just mention, when it comes to databases, that we've been using this quite successfully on SQL Server as well, where it definitely improves performance. I do believe that the algorithm is of the kind where you do a little bit of a trade-off between performance and memory. So this is a memory intense algorithm. It likes a lot of memory, which could be a case where if you have an extremely large table that doesn't fit well or scale well into memory, or if the database engine doesn't properly use memory when it is working with this, that could be an issue. But I'd just say, like Erik did, that test it for yourself. It's not that complicated.
So I'm just gonna jump ahead a bit here.
Carl, you have a question?
Yes, unfortunately, Erik just paged away from the code. So
you want to see the code again?
Yeah, so two questions. First, yeah, this one. So is this the kind of code that you would populate as a template, say use the DBT to put in your facts and dimensions to do comprehensive twines for all your facts and all your dimensions, or is it like always a manual compiling, or is this kind of the how can I say, making the twine? Is that something that is works good with a template and data?
Yeah, for sure. Because if we will take it here, is that all right? You have, for instance, say you would have the same case. The thing you have, okay, you have two in DBT models, okay? You have a time point that you need to define from one of these. And then you get the timeline based on the table, so that you get for free. And also, of course, in this case, the customer ID, it could be the dimension ID. And then you basically, the algorithm here with this sliding window function here will always look the same. So this is 100% doable with a dbt macro. Because I mean, we did it in Ensemble, but then we used a Lua script instead, which is the thing there. So it's super easy to automate.
And second question is, performance-wise, would it be a material difference if you did, you're doing, how can I say, from outside in, but if you did from inside out with common table expressions, does it have a performance impact or so?
I guess that depends on, I mean, what is your infrastructure, and also in combination with the amount of data, in this case, the sales table and the customer. So it's a little bit of both. But with Exasol, which is an in-memory database, it's, I mean, crunching, what was it? I can't remember. 3.5 billion transactions in combined with 18.8 million unique customer version, and it takes 7 minutes. I mean, it's an indicator at least.
Thank you.
Okay. Yeah, moving on. If there, oops. We can have a recap of questions later. I'd like to continue now, so I don't take more of your time than necessary. Okay. The second use case is the ensemble to dimension, because normally, right, in a data vault ensemble, you have multiple satellites, and I just noticed it before logging in here. I got a little bit, because normally I prefer to have the S prefix at the end, so we have the ensemble together. But I'm in the current project that I work in, I didn't start at first, so they kind of had the S_H_L_ prefix at before rather than after, which disturbed me a little bit. So, but anyhow. All right, so normally, right, you have multiple satellites on connected to a hub, of which you would have a dimension in Kimball-style dimension. And since these, right, all of these, in this case, 3 satellites have their own timeline, it is not super easy to extract what version in this satellite was in effect with the version here and the version here. So we have here an example here on the bottom, right, that this main here that I said, well, it was in effect on the 1st of January 2022. This is my name, and here you see some address information and some preferences, whether or not I allow some communication through different channels. And since if you're not experienced with data vault, this is really hard to extract that at this point in time. My preferences for communication was true, false, because given the timeline here. So what we normally do, and now it's okay if you don't see the table here underneath, because what has been a normal pattern, right, is that we have a so-called point in time object that calculates which that goes through all of these combinations and make it unique here, and then tell you what version in the main versus address versus preferences should I look at this particular date. So normally when we have this artifact and we're loading it to the dimension here, first we reading the satellite, load it, or make it as a view in here. But then, right, the dimension is our end table here. That's our end destination. we start reading from this and then read from the satellite once more. So here, and the code could look like this. I copy pasted it yesterday from one example where you see here these range joins from, a lot of range joins going on. And of course, if you add, because it's not, I mean, it's common that you will have 6 or 7 satellites for some dimensions. The complexity of this query improves. Or I mean, yeah, it gets worse. So what I did then was to see, all right, is it possible to keep the point in time table, but use the Twine code instead? And it looks like this. It looks exactly as the previous example that I showed. The only difference is, in this case, we have 3 sources, and we don't select one of these timelines, because in this case we want all of them, right? So, and that is it. Otherwise, it is the exact same code pattern as the ones where we were syncing the fact and dimensions. But then I was curious, all right, this seemed easy. Is it possible to, with the Twine, to bypass the point in time? And then the code looks like this. So instead of ending with the, here where is it? Or here where we here in effect, right? Which version from each satellite was in effect at that point in time? Simply just rejoins the satellites again, and then we load the dimension without any point in time at all. And again, this is it's such a strict pattern that it could easily be automated, which we have done in the current project where I work with, that we use TBT. So what we see here is our SQL file, which is nothing but YAML, where we say that, okay, this is the D-customer SQL table, by the way. We say, well, we specify some things. We set what historization level we want. And here we can have current day, all, weekly, year, whatever. And then we just specify the hub and the satellites we want to use. And since the Twine pattern is so easy to work with and automate, we have hidden this logic inside a macro, which here is called dim, and that is it. And one of the reasons we needed to do so in the project where I am is that we are 7 or 8 teams working in different product areas. And we are likely around 40 data engineers. The vast majority of them has no or minimal data vault experience. So this was kind of a prerequisite in order for us to be productive, that we simply have hidden all the temporal logic inside a macro and let the data engineers only, specify metadata to it in a YAML structure. And that was basically it.